Hello friends and welcome back to our today's tutorial. In today's tutorial, remember we're still discussing radical expressions or surds expressions, and today we're going to look at how to multiply surds or radicals. But before then, I want you to know some of the rules that are guiding this so that it will help us in better understanding on when to multiply and when not to multiply. So I encourage you to stay actively through the end of this class because you have a lot of skills to learn. Now let's take a look at some of the rules guiding this. In the course of this tutorial, remember multiplication, we are using this, either this or this. These are the signs. Okay, so I can be using the two interchangeably in this tutorial. So the rules guiding this, let's look at the first one. We have it that when you have the same index, remember in our previous tutorial, when you have a radical of this form, we call this the index. Okay, you can watch our previous tutorial to see our discussion on that. And this is what we call the radicand. And we said that this index in multiplication, if they are the same, you watch, you are free to multiply. Okay, so in that case, you are going to multiply the radicands. So you see it here. So let's look at example to illustrate that. Supposing we have root 3 is multiplying root 2. You will notice that the indexes are the same. Here is square root. Okay, this one is also square root. So you can multiply. So in the course of multiplication, you are going to multiply 3 by 2. And when you do that, it's going to give you square root of 6. Now, which other cases do we need to know? You also should know that when the radicals are with coefficients, how do you multiply them? To multiply radicals with coefficients, we multiply radicals, we'll be multiplying radicals, and coefficients, we multiply coefficients. Okay, so this is just a clear picture of what that means. Now you see this is just a radical term on its own, and you notice that their indexes are the same, so you are free to multiply. So this will multiply this. This is called the coefficient. Okay, that number before that root is the coefficient. Remember, it is different from when you have this. This one here is index. Okay, but if you have something like this P here is what we call the coefficient. So when you have it this way, the coefficient will multiply itself, you see it, then the radicands will also multiply, provided that the indices are the same. Now the next thing to note under this is example. Now supposing we have this, if you are to multiply, you notice these are the coefficients. So you multiply 2 by 5 to give you 10, and you multiply the radicands, it will give you 3 multiply 7 will give us 21. So this is what we have. Now the next rule is when the radicands are multiplying each other. Example, when you have something like this, what you simply do is just to take one of the radicals and then raise it to a power. Okay, take one of the expressions and raise it to a power of 2 because they are 2. If they are 3, you also raise to the power of 3. So in this case, let's look at this example. So you notice that this is the same with this. So what you simply do is just to take one of these, and because they are 2, you raise to the power of 2. So you notice these 2 now, we cancel the square root. Okay, remember we said this is square root. And when it does that, you are going to have 3 as an answer. Let's take another instance on this. We can have cube root of 2 is multiplying cube root of 2 is also multiplying cube root of 2. You notice that these are all the same. So you can just simply take one and then raise it to the power of 3. Okay, then this 3 will cancel this cube root. You will still have 2 left as an answer. So I hope you have seen how to make use of that. Now the next one is the fourth rule. The fourth rule there are cases when the indices will be different. I hope you've not forgotten what we introduced as the index. Okay, when you have the indices to be different, what do? You cannot multiply them, just like the ones we've discussed earlier. So what you would simply do is to express it as a fractional exponent. Now let's take a case of this. Okay, you notice this one is square root and this one is cube root. So what would you do? what you simply do is to express this as an exponent. Just remember your rule of indices, okay? Which says that a to the power of 1 over n is use the denominator to form the root, okay? And raised to the power of 1. So in this case, it means that this can be expressed as this. So when you have this, remember the power here is, the index there is 2. So it means that this a is the same as a to the power of 1 over 2, just like this, okay? Now this one will be what? A to the power of 1 over 3. So just follow through in this tutorial. You will see how to solve such problem, okay? Now let's look at this example. When you have this, what you simply do is 6 to the power of half, then multiply by 4 to the power of 1 over 3. Then if you have it this way, it's going to give you x to the power of 1/3 is multiplying x to the power of 2, then all over 4. I hope that is clear. So in the course of this tutorial, we are going to see how to simplify such. Now that you've understood these rules guiding this particular multiplication, let's now look at how to answer or simplify some of these problems. It is very simple as usual. So what would you do now? The first question we have there, we are asked to multiply, okay? So to multiply this, what would you do? We take it from the first one. So what you do simply is, remember the indices are the same, or the index, okay? So you multiply the radicands. So you have solution now. So we have root 3 multiply root 5. Will now be, this will be used to multiply this. So we're going to have, take one root, then 3 we multiply 5. And when you multiply this way, it gives you root 15. And root 15 is a prime root, okay? It is a prime surd. It cannot be reduced. Why? Because there is no perfect square in this. You can follow our previous tutorials to know more about perfect square, okay? So that is the solution to the first question. Now let's look at the second question. In the second question, this is what we have. We have 5 root 3 multiply 2 root 18. Now when you look at this question, you will notice that this value here has a perfect square in it. The two ways you can answer it is, you can first bring out the perfect square in it first and then multiply, or you multiply and then bring out the perfect square. Whichever way you want to do it is okay. But for me, I will choose to bring out the perfect square in it first and then multiply. So in that case, I know that 18, the highest perfect square in it that can be multiplied with a number to get 18 is 9. So in that case, I'm going to have 5 root 3 is multiplying 2 roots. So I reduce this to 9 multiply 2, okay? And remember, 9 is a perfect square. So each square root will give us 3. So we're going to have 5 root 3 multiply 2. Then this 3 that we got from here, you bring it out from the root. These 2 will remain in the root because it's not perfect. So we leave it as root 2, okay? So if you multiply this, you're going to have 5, we multiply this 2, we multiply this 3. Remember we said coefficients, we multiply coefficients, and the radicands, we multiply radicands, okay? So 3, we multiply this 2, and when you multiply this, it gives you 10, and that is 30 root 6. And this is what we have as an answer. But remember, most times when you do it this way, by first simplifying to remove the perfect square, at the end, there may still be perfect square in your answer. Just be watchful of such. So if you have such where you have done your work and there is still perfect square, please remember to reduce it, okay? Until you reduce it, that is when you have simplified it. I hope this is cleared. Okay, now, if you are really enjoying this tutorial, it means that what we are doing is really impressing you. Please don't forget to tell us how much in the comment section. Remember, you can subscribe us for the more you get from us. Give this tutorial a thumbs up. You can share with your friends and colleagues and students that need these skills. Now, let's continue. So to answer the third question, you see, it's becoming interesting. Now, let's look at the third question. So to answer this third question, what we have there is root 80 is multiplying root 20, just this. So what would you do? You can choose to reduce this and then multiply, okay? Now, what is the highest perfect square in 80 that you can multiply with a number to give you back this 80? That's what we want. That's what we mean. So the highest perfect square there is what? Is 16. So we're going to have 16. And when you multiply 16 by 5, it gives you 80. I hope this is cleared. Okay. Now, what do we do next? This will be multiplied by the highest perfect square in 20 is 4. Such that when you multiply it by 5, it gives you back what? 20. I hope this is cleared. Okay, now what do you do next? You are going to simplify 16. The perfect square in it is this. So its square root is 4. So you bring out this from the root because it's already perfect. This will remain and we have it as this. Multiply by 4. Its square root is what? The square root of 4 there is 5. Is 2. So we have 2. This will remain because it's not perfect. Did you see that? So what do you do now? Remember the coefficients is multiplying coefficient. So 4 we multiply 2 to give us 8. And the radicals multiply. Remember, you see now the radicals are the same. So like we said it at the beginning, you raise it to the power of 2. So we are going to have 8. We multiply this to give us 40 as an answer. So let's go to the last question. I hope you are really enjoying what we're doing. You see that radical is very simple, especially when you are familiar with the rules. Now the last one there is, we have cube root of 18 is multiplying the cube root of 3. Now what do you do there? What you do there, you can simplify this. Okay, we can simplify to get the perfect cube in this 18. What number can I multiply 3 times to give me 18? Is there any? We have 2 times 2 times 2 will give us 8. And 8 times is not 2. So what number? You can think. What number do you think we can multiply 3 times? So it means there's no number. So what you would simply do is just to bring these two together. Okay. So if you bring that together, we're going to have the indices are the same. So you take 1, just like we have explained, and you now have 18 will be multiplied by 3. Did you see that? So what would you do now? Multiply 18 by 3, and this will give us cube root of 3 multiplies 4 is 24, taking 2. So we have 54. So we're having cube root of 54. So what would you do now? You are going to get numbers. So let me just show you the best way, the shortest way. We are going to divide this 54, choosing the least number that can divide, which is 2 because it's even. So when it goes there, we have 27. When 3 goes is 9. 3 here is 3. 3 here is 1. Now because it's cube roots, you're going to take them in threes. So look out for the one that appeared 3 times, and that is 3. So take one of it out. So in that case, we are going to have this value will give us 3. The 2 will remain inside the cube root because it's not perfect. So this is what we have, and this becomes our answer. And I hope you really learned a lot in this tutorial. If you did, please don't forget to tell us how much in the comment section. You can subscribe for the more you get. Remember, you can share this tutorial with your friends and colleagues, and don't forget to give it a thumbs up. I'll see you in our next class to discuss more. Till then, stay cool and bye-bye.